Hey guys, today we're going to be talking about combining like terms through addition and subtraction. Kind of our level 1 of combining like terms, if you will. Now we're not going to talk about things like if you have a 5 and a 3 in an expression. That's pretty straightforward. We know what to do with those numbers. We've been doing that since we were in elementary school. But we're going to be talking about what happens whenever we have things that look different, like numbers with variables. So let's say we have an expression that looks like this. 6x plus 5x plus 3. Now we have 3 different terms here. But does it need to be written as all 3 terms? Can some of these terms be written together? Well, in this case, some of them can. You see, to combine like terms, we have to have 2 things be the same about our terms. Sorry, I know I'm using the word terms a lot here, but it comes up. It's a popular term. So, what I like to say is that our terms have to have the same variable configuration. Now I'll be honest and say this is kind of a term of my own. This is not necessarily a fancy math term, but just kind of something that I use to remind myself what I'm looking for whenever I'm combining like terms. And to me, a variable configuration consists of 2 things. It consists of the variable itself, meaning an x or a y or an x and a y, something like that. And then it also consists of the exponent of the variable. So is it, x to the first? Or is it x to the third? Or x to the 42nd? Something like that. For us to combine 2 terms, or more terms than that even, all of the terms that we want to combine must match on both of these factors. The variables must be the same, and the exponents on the variables must be the same. So whenever we take a look at an equation like this, or an expression, sorry, I get those terms swapped all the time. But whenever we look at something like this, and we see our variable terms, we have 6x, and then we have a positive 5x. Do these terms share the same variable configuration? Well, let's check. Do they have the same variable? They do. Both of them have an x. That's exactly the same. It's not one with an x, one with a y. If they were different letters, then they wouldn't match. And then we ask ourselves, do they have the same exponent on that variable? So let's take a look at this x. What exponent does it have? Is it 6? Because that's the number in front of it. No, you're right. That's not an exponent, right? This 6 is a coefficient. That's telling us how many we have. That 6 doesn't matter for the variable configuration. The exponent is found as a superscript to the variable itself. It's the number that would be written right here in the corner after the variable. Now we don't have one on here. That doesn't mean it's 0. It's that invisible 1 idea, right? Whenever we don't write it, it means it's a 1. It's x to the first. Does this have the same exponent? Is this also x to the first? And it is. That is also an x to the first power, or we just call it x. So it works on both of these 2 criteria for us to be able to combine the terms. So let's go ahead and do that. Let's combine these terms. Now the way I like to think about it is, we have 6 x's over here. Let's say we're talking about like apples or something, right? We have 6 apples in this hand. And then we have 5 apples in this hand. So how many apples do we have together? Well, we have 11 apples, right? Together, 6 here and 5 here, that makes 11. That makes sense logically, but why mathematically does it work that way? Let's look at it like this. We have these coefficients that we mentioned earlier. Now, they didn't come into play here, but we know they got to be important. 6 and 5 make 11, right? And we have this plus sign in between them. 6 plus 5 is 11. What happens whenever you want to combine your like terms is you need to combine your two coefficients. And when I say combine, I mean do the operation between them, or do the operation connected to, this second one that you're adding to it, or adding in this case. So we would take 6 plus 5 did 11. Does the x change? I don't know. What do you think? Whenever we use the example of the apples, and we have 6 apples here and 5 apples here, when I say, okay, I have 11, is it still apples? Is it still the same thing? Absolutely it is. They're not like super apples now or something since I put the 2 handfuls together. So it's still just x. It's still that exact same variable with the exact same variable configuration. That doesn't change at all. Now, can we add the 3 with these? No, that we can't do because it does not share a variable at all. And, obviously the second criteria doesn't even come up since it doesn't have that variable in common. So we would keep the 3 where it's at. It would just kind of drop down and we'd say, okay, 11x plus 3. Now I know that's a really long-winded explanation as to how this works. So I'm going to kind of speed up that explanation a little bit with our next 2 examples that we're going to do. I'm going to put 2 problems up here. The first one being x squared plus 5x. Let's actually make this 3x squared. 3x squared plus 5x. Can those combine? Can we add those 2 to be a new term? Well, let's take a look at this with our variable configuration idea. Do they share the same variable? Well, both of them have an x, right? So like just in terms of what variable it is we're talking about, x, they do both share that. So we're okay on that front. What about this second one? The exponent of the variable. Are their exponents the same? That's where we're led astray. This is x squared, this is x to the first. So we notice a problem when it comes to that spot right there. They do not match, therefore they cannot combine, and there's nothing we can change or evaluate about this expression right now. Now what if I wrote another expression? What if I said, 7x plus 8x plus 5y. Is there anything I can combine? You're right, we can combine the 7x and the 8x. 7x plus 8x makes 15x. I almost got that wrong, but luckily I caught myself. 15x, but can the 5y add into this as well? I don't know, what do you think? Could that make it 20xy? Well, let's use that example again with the apples. If I have 15 apples in this hand, ignoring the fact that's a lot of apples to hold in my hand, but if I have 15 apples in this hand and 5 oranges in this hand, then do all of a sudden I have 20 apple oranges? Is that what we would say? No, we would still say I have 15 apples and 5 oranges. We would say that separately. Just verbally, we're going to say that separately. And that's what happens here too. We have 15 x's and 5 y's. We can't combine them because logically, these are 2 entirely separate entities. They're 2 entirely separate variables. They can't combine through addition or subtraction. In addition to the fact that it just breaks our first rule of the variable configuration. I wanted to give that apple orange as an example as a way to kind of remember why the variable configuration is important, why that works, why that's a rule. But it does violate that first rule. The variable itself must be the same. Are x and y the same? Absolutely not. So this is how it would stay. This would be the final evaluation of this expression. So that about does it for combining like terms through addition and subtraction. If you have any questions, drop them below. I'll answer those if I have the opportunity to. Otherwise, thanks for watching, guys, and I'll see you next time.